just record this. All right, so fix that on that first line. Would you have your hand up? Yeah. Okay, so I want to recap that whole idea and then we'll go back to it. Okay, and you know what, let me just write down who's absent since we got a ton of people absent so that I don't forget when I go and do. So Lucas isn't here, Audrey, Taylor, Katie, Samantha, Adam, I saw Adam today. Okay, so let's recap what we're doing here on these ideas, right? Recap the limit lines, right? So I want to be able to rewrite it on here, nice and neat, okay? All right, so what we were looking at last class was end behavior, right? End behavior of the graph. So, Garrett, there were like 4 categories. Do you remember any of the categories from last time? And look at your sheet too.
Even, odd, positive, and negative.
Awesome. So, let me try to draw it the exact same way we drew it last time, right? So we went this way where the things are even versus odd. Feeling positive? Positive. This was positive. This was negative. Right? So these 2 items were talking about the leading coefficient, and these 2 items were talking about the degree. Right? So we have this statement: limit of f of x goes somewhere as x goes somewhere else. Right? And we were saying in this x spot, for the end behavior, we're either going to put a positive or a negative infinity. The positive infinity means we're going to the right. The negative infinity means that we're going to the left. So in all of these functions, I kind of say it's like the no-brainer part, right? You need to just write that 2 times for each of them. All right, so I'm going to be lazy, and I'm going to say, okay, I'm going to take that, and I'm going to copy it. It's not copying for me. All right, I'm going to paste it down here. I'm going to paste it over here, and I'm going to paste it over here. All right, so that's kind of the no-brainer part, right? Now I have to think about stuff, okay? So I talk about it maybe a little different way than your algebra 2 teacher would talk about it, right? So when a leading coefficient is positive, that means right-hand side of the function goes up, right? So I'm going to do a little model. Right-hand side of the function goes down. I'm sorry, up. When it's negative, right, right-hand side of the function goes down. So then when it's even, so I'm going across, arrowheads are in the same direction. When it's odd, arrowheads are in opposite direction. So remember, OO, opposite is odd. Okay, so you guys remember that from last class? Okay. So then I remember Garrett saying we needed a little more clarification of how I'm rating the positives and negatives, right? So you want to think, if these arrowheads were points, right, what points would they be? If I go very far to the right, right, so I'm talking about this arrowhead right now. If I go very far to the right, that's positive infinity. Pointing up, that's positive infinity. So x is going to the right. F of x is going up, right? So then if I try to do this one on the left, right, x is going to the left, so that's negative infinity. Y is going up, that's positive infinity. So the direction, the arrows really have 2 directions, right and left, up and down. So if I take this one, it's going to have a right, it's going to have a left. All right, so this is my going to the right, this is my going to the left. They're both pointing down. So that's negative infinity for both of them. Again, on this one, it has a right, it has a left. It has a right, it has a left. Now you're going to think about what direction it's going. The right arrowhead is going up. The left arrowhead is going down. The right arrowhead is going down. The left arrowhead is pointing up. Okay? Dad, is that a little better? We got to do some more examples. Is that a little better? Better? Yes? No? Okay. All right. So now let's look at some of those examples. Right, where am I? I am right here. All right. So the one that you had for homework was B, right? So you're going to decide what's the degree and what's the leading coefficient. So you look at that polynomial, I would circle x to the fourth, right? So the fourth is the highest number. So that means the degree of B is 4, which is even. So even means the same, right? That's what even means. The leading coefficient on B is a positive 1. So it's positive. So that means right-hand side is going up. So positive is it. So now I know it's the same. So I know this one also has to be positive infinity. So you were supposed to do B for homework, right? So it should have been 2 positive infinity. Okay? All right, so let's try a couple more. So the ones down below, right, we're going to do a different form for that. And that kind of includes the ones coming after that. So we're going to go back on here. And I put 4 on the next slide. Right? So first thing I want you to do on those 4, you and your partner, right? I want you to decide, is the degree even or odd? And then is the leading coefficient positive or negative? All right, so you can put, so these, I don't think these are in your packet, or notes, right? So even or odd for the degree, and then leading coefficient, positive or negative. This week I don't know. Maybe like a quick check-in. Probably something like just like this, is maybe put a limit on it. Maybe if we had another day, I might like extend it a little bit. Yeah. Because what, today's already Thursday? I mean Wednesday, right? All right, so you guys should be deciding on 4 of those answers right now, right? Even, odd, positive, or negative for each of them.
Negative.
Why is this not working? So annoying when this doesn't work. So I'm going to have you guys go put an E or a O up there, a positive or a negative, right? That will fill in the behavior together. And they need more time to fill those in. They should be pretty quick, right? E or O, positive or negative. Right, so why don't we have four of you guys just go put an E or an O? So, Rufini, can you go try something? JC, Penny, and Caitlin. So just on any of the four of them, just go put an E or an O. That's all I want you to do. An E or an O. E or an O. E or an O. All I'm asking you is the degree of the polynomial. And you have to decide if that degree is either an odd number or an even number. That's all I'm asking you to do. The degree of the polynomial is the highest power. Okay, you guys don't need to put E or O, you just literally put E or O.
Please excuse the interruption. We're following students. Please report to the testing corridor at this time. Natalie Antonio,
I got 5 people in
Anna Barros,
or you guys go
Oscar Baracco, Faith Barrett,
What is that?
Courtney Brady, Ellery Breeding, Lily
Or you
Brown,
guys go up and put positive or
Jane
negative?
Bryant,
So maybe either
Annabelle
or
Buddy,
gals, since you guys are the
Sophia
same partner.
Cancelleri,
So Jillian and
Olivia Cannon, Sarah Chang, Marie Choi Shadow, Katie Chun, Sabine Platis, Lily Cregan, Riley Curran, Lily Dessel, Allie Dubas, Glenn Fullaway, Anna Garapana, Jenny Geiser, Stella Hilliard, Emily Moore, James, Bernie Johnson, Kyle Keogh, Piper Kirkwood, Indy Lamb, Riley Leadham, Jasmine Malik, Abby Martell, Alex Martin, Emma Marvelli, Maisie McAdams, Megan McCran, Leah Medeiros, Kate Mellon, Roxana Mohammadi, Grace Moore, Maeve Murphy, Emma Pauk, Lainey Reed, Alexandria Rigo, Caroline Resnick, Jordan Roskowitz, Grace Saul, Virginia Sanderson, Maddie Watson. Those students to the testing corridor at this time.
All right, so we got 8 answers, right? So, Julie, you didn't want to go up. What are we looking for? What are we looking for in all of these equations? Like, what do we have to pick out? What has to be highlighted?
Oh, the exponent.
The exponent, which one? Can I pick any one?
The leading coefficient.
Okay, so which one tells you that it's the leading coefficient?
The biggest exponent.
The biggest exponent. So if I happen to put them all in descending order for you, right? So all the ones that I put in as a rectangle, right, is going to be called the leading term, right? So then we're going to look at that. 4 and 6 should be even. 3 and 3 should be odd. And then the sign, positive, negative, negative, positive, positive, negative, negative, positive. Right? All right, so I'm going to say no-brainer part, right? What can I fill in without even thinking?
For the even, it's going to be the same number.
Okay,
Good.
so, well, not necessarily, right? So I'll put my first thing kind of not thinking at all. I'm going to put on the first and the third, they're the same, right? So if I find one, I can automatically find the other. Say again? Because if it's even, they're either both going to be pointing up or both going to be pointing down. Okay? What else can I fill in without really thinking at all? What can I fill in? What did I go and fill in? I don't know what, on this chart, right? I did number 1, I talked about it, right arrow, left arrow. I did this one, talking right arrow, left arrow. Then when I was in these 2, I automatically filled in 2 of those 4 spots. Does anybody remember which 2 I filled in? The left and the right. Right? That is correct. I won't say right? So that means the right is going to go to positive infinity always. So all of them, I can fill in positive infinity for one of them. Well, I don't know which one it is. It doesn't really matter if it's this one or this one, right? But I know these are all polynomials. So they're going to all look like this and like have some squiggles, right? But they're going to be continuous going on forever.
But they don't always go to infinity. I mean, positive infinity.
Um,
In this case they do, but
In
not
this
always.
case, they
Like,
do.
how much do you think?
I didn't tell. How do we tell that?
No. We're doing this part. I'll talk about that sheet in a second,
I
okay?
didn't know.
So we know that it's a polynomial, right? It's a squiggle, right? So remember our basic parent function, a quadratic, a cubic, right? These wouldn't be a square root, right? So all of these problems look like this, all of them. So I know it's going to go on forever. So I know it's going to continually go to the right and continually go to the left. So if I make this column my right column, well, it's going to continually go to the right. If I make this whole column my left column, it's going to continually go to the left, right? Now, the more important part is I have to fix whether it's going up or down, right? So if the leading coefficient is positive, my right-hand side goes up, right? It's going to look like this, right-hand side up. Now that I know it's even, Jillian gave us the same, so it's the same, right? So on this one, it is a negative leading coefficient. So that means right-hand side goes down. It's odd, so that's opposite. So then if I fill in the other two, negative, so that means right-hand side is down. It's even, so it's the same. This one was positive, so that means right-hand side goes up. It's odd, so that means opposite. So
I guess.
positive means up on the right, right? Even means the same, odd means opposite, right? Negative means right-hand side goes down, same deal, even, opposite. All right? So I think I have one more set. All right, one more set. So, I mean, yeah, I know you say that, Graham, right? But again, you have no idea what you might do in school, right? For lunch. Oh, sorry. Yeah, right?
But I do.
But you don't know what you're going to end up doing. So this stuff is needed
Certainly
for
not ready for the math.
higher maths, right? So, I don't know, is math plural? Higher math.
like.
If you're gonna, not necessarily like engineers and that type of engineers, right? Different types of things are gonna need, even nurses and stuff like that, need different types of equations and know what's gonna happen. Okay? All right, so Adam, are you good? All right, so do these four. So all I want you to do on these four, right? So last one, you guys wrote the even and odd. On these four, I want you to write the limit lines. Right? These four, I want you to write the limit lines. So you're going to have to decide if it's even or odd, positive or negative, right? This one? This one? Yeah, I can put them like that, Graham, or I can put them like this. The order in which I say them doesn't matter.
But as long as like the first ones left there are always.
No, that doesn't matter. Right? Because I can put them like this, or I can put them next to each other. It doesn't matter. What has to be together is this has to be together.
Yeah.
So this means left-hand side goes up. That's the important part that has to be together. Okay? So if we want to write it like that, again, I'm going to be lazy, right? Because I think it's a pain to write this so many times. I'm going to go and copy it and then paste it in my other 4 spots. All right, so this is like the no-brainer thinking. I don't need to think about what I'm writing right here. It's just the setup of it. All right, so you guys go think what has to be in those empty arrow spots. That is always the same. Yep. So now you should be thinking positive or negative. That controls the right. So that controls the positive infinity. Right? So positive and negative controls the, no, positive and negative controls the right. So positive is up, negative is down. Even and odd controls opposite or the same. Even is the same. Even, equal, odd, opposite. E-E-O-O. So positive and negative control the right.
No, I just, I got my notes.
Yeah, it's not, it's in notes, Luke. There, come on. Did anybody do Chinese this year? Chinese, did you do it last year too?
How does they get to teach Chinese? What do you mean?
Why do what? It was a language that a lot of students actually asked to have, and that's how it started. So why those students wanted it, I don't know. I mean, Latin, I think, is an awesome language, because that's a lot of, like, groups of words. You've done these 4. Yeah, you're filling in these 8 blanks right here. 1, 2, 3, 4, 5, 6, 7, 8. And they all should either be a positive or a negative infinity. I can't tell which one goes to this. That's the top piece, the bottom piece. So then, yes, this goes to those out. Because on the right-hand side, which is that piece right there, it's pointing down. So the right and on, you go to the right, and that's positive and negative. It's pointing down, so that's negative. The left hand, if you want to make it that way, it doesn't matter. All right, do you guys, again, this shouldn't take long, right? So do you guys agree on those 4? So I did all of those 4 by doing positive or negative. Right, so I looked at leading coefficient first. I looked at them all together, and I said leading coefficient positive, leading coefficient positive. So right-hand side goes up, all right? So then leading coefficient negative, leading coefficient negative. So right-hand side goes down. Is that okay? right? So now I'm going to decide even or odd. And again, I'm going to do them together. These two are even. So same, same. These two are odd, right? So opposite, opposite.
Wait, how was the first one that one the other
Yeah.
for yours, top on the left, bottom on the right?
These are the right because it's positive infinity. These are the left because it's negative infinity. Okay? Yeah. So you have this one, let's say, for example, down below. Nope, doesn't matter. The only thing that matters is these two are together, these two are together, right? But Brennan, it can't be flipped, right? So like on this one, I can't have negative infinity up top and infinity on the bottom. The f of x has to have the positive infinity, the x has to have the negative infinity, all right? Okay, so we're going to do the exact same thing, but I'm going to make this look just a little different, okay? And the little different I'm going to make it is I am going to make it so that it's factored, okay? That's the only change I'll make, okay? So a zero of a polynomial, right? So a polynomial, I'm going to make a nice short one right now. A polynomial is something like x squared plus 3x minus 10, right? So that is even, and that is positive. So I know that it looks like that, right? I know it looks like that. I can rewrite that in a different form and be the same exact thing by factoring it. So this is the factored form of that same polynomial. So all I did was factor it. Factor the 10 to get you a 3. So the benefit of the factored form is going to give you the inside part of the function, right? Inside part of function. Look, we following this back there, sir? Okay. So the zeros of the polynomial, if I take the factored form and set it equal to 0 and solve, I can find the x-intercepts. So I can tell what's happening on those 3 dots. Okay? So I'm going to draw it just below so I have enough room. All right? All right. So this says if I have a factor of x plus 5 and I set it equal to 0, that means the x-intercept hits at negative 5. So I know there's a point on that parabola. It also has a factor of x minus 2. If I solve that, I know it hits at positive 2. All right? So we haven't talked about degree or sign leading coefficient. All right? So I know my degree to be 2, which is even. I know my leading coefficient to be positive, which means right-hand side goes up. Even means it's the same. So I'm going to connect my arrowheads. I'm going to make it go through my zeros, and I can get, whoops, that was supposed to go through, right? I can get a pretty decent graph knowing what happens in between. Okay?
Can you,
Yeah, we're just going to do a different one, but I want to just finish my statement on this one, right? Okay? If it has a degree of n, right, then I need at most n zeros. So if my degree is 2, then I need 2 zeros. So I know it's not gonna hit any more times. So let me write another one, right? And I'm gonna explain the exact same way. Say that again. The arrows, I determined the arrows by knowing from this part that my leading coefficient was positive. So that means right-hand side goes up, right? Positive leading coefficient. And then it was even degree, so my left-hand side also goes up. We're going to do that right now. I was trying to do both, and now I'm going to give you this and show you how to get it. Okay? All right, so let's do another one. All right, let's do another one where I don't give you the whole polynomial. All right, so let's say I give you negative x plus 1, x minus 2, x plus 5. Okay, so I'm giving it to you in the factored form. And we're going to do the exact same thing, except a little extra by knowing where it hits. Okay? Yep, so the first thing I want you to do is I want you to take each one, set it equal to 0. So again, we're adding a piece. I take each one, set it equal to 0, and solve it. Negative 1, positive 2, negative 5. All right? So those are the zeros. What makes the parentheses equal to 0? All right? So I am going to go and plot them. I'm going to say, okay, it hits at negative 1, it hits at 2, and it hits at negative 5. So I know it's going to hit the x-axis in that manner. Okay? So now I need to decide where my arrowheads are. Is it even? Is it odd? Is it positive or it's negative? Okay? So there's going to be a few different ways that we can determine even and odd. Right? But right now, here's 1 0. Here's a second 0. Here's a third 0. So I know the degree of this, right? We just put an n in here, has to be the same. So the degree is 3. It has 3 zeros. Okay? And again, I'm going to do another one that's going to be a little different, but that's okay. The degree is the highest power. If I multiplied this whole thing out, it would have x cubed plus blah, 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 blah. Okay, so that's the form that we started with. Whatever the sign is right in front, right there, would also be multiplied through. So that means the leading coefficient is negative. So you're going to see it right there. It's going to stand out right there. If there's nothing there, then it's a positive. So leading coefficient is negative. That means right-hand side goes down. Degree is odd. That means opposite arrowheads. And now I'm going to connect the dots. Connect, connect, connect. We don't know like how high and low those mins and maxes are. Okay? So we're adding the piece of zeros. All right, let's try another one. All right, let's try x plus 3, x minus 1. Let's stick an x out front. And then let's go x plus 4. So I think, so Graham said he's going to take each one and set it equal to 0. I don't think you guys really need to do this. I think you could tell me what number makes each of those parts 0 without actually doing an equation. I think you guys can tell me that. All right? Holden, what number can I plug into x to make that parenthesis 0? Negative 4. Garrett, how about this one? What number can I plug into x to make that 0? I can do 1. Right? Darren, how about this one? -3. All right, how about the hard one?
Zero.
It's 0. Right? That one is 0. So that one's right there, 0. So those are where it hits. Okay? Taylor, how many zeros are there? How many times does it hit? 4, right? So that means degree is 4, which means it's even. JC, how about our leading coefficient? Positive or negative? Positive leading coefficient. So that means right-hand side is up. Same or opposite? Same. So connect the dots. So it looks like another. All right? Okay, so we're going to try a little different one. Okay? So another way you can tell the degree, right? Because sometimes things are going to be a little funny, right? If you look at all of these X's, and you look at the power of all of these X's, excuse me, what do all those powers, they're all 1. How about if I add them all up? I get 4. So that's how you're going to also get the degree, right? You can add up all the powers. You will say?
Am I allowed to recheck my graphing calculator?
If you want to, just come back here.
I have a question.
All right? Let me just finish my sentence, right? So all you have to do is add all of those powers up. Okay? Yes, sir.
So if it's like 2x plus 3, 4x plus minus 1.
2x plus 3.
No, I'm just using the one from
Yep.
above.
4x minus 1.
And then like 5x plus 4. You do the same thing.
Yep. All of these powers are 1. So it would be a degree of 3. I guess I don't know what your question you're asking me. Are you asking me to like do the whole thing out?
I don't know.
Well, the degree would be 3. There'd be a 0 at -3 halves.
So wait, but do you have to like solve it? Like make them all equal to 0?
Yeah.
Like,
When they'd be fractions, I would do that. Yeah. Okay? All right, so let's try one that looks a little different.
let's just keep it to x.
Well, this is our different one right here.
Whoa.
All right? So how is it different? It was all done, like 30 packed off. We're not done yet. Right? So what do you think the degree is on that one?
3.
I had 2 and I hear 3. Right? So it's 3. 3. Because this guy, this one right here, appears twice. There's 2 of them. Right? There's 2 of them. So this degree is 3. So when you have an exponent up there, right? When you have an exponent, and if I were to multiply that all out, it would be a squared term, right? So think about this as having it happen twice, right? Having it happen twice, and then 1 more. So the degree is 3, right? Yeah?
So like, I don't know if this is one question, but when you're like plotting it,
Mhm.
how do you?
It's weird, so that's what we're going to see what it looks like. So we're going to connect the dots and see what happens, right? So, and that's the purpose of this one, is what happens. Because Darren's saying, I can't make it go and hit -3 twice, right? That's weird. So it hits at -3, it hits at 2, right? How about right-hand side, up or down? Positive leading coefficient. Up, right? Same or opposite? Opposite. All right, so I'm just gonna like plot it a little bit. So if I connect the dots, I'm gonna connect. Oops, what has to happen? I gotta come back down, right? But there's no other place to come back down. Okay? So you could do the y-intercept. Okay, you could. This is how you can tell what happens. Okay? When these items are squared, or to the 4th power, or to the 6th power. What type of numbers are those? 2, 4, 6, 8, right, Brennan? Good, they bounce off, right? So this right here is called a multiplicity. So that's a new word for you guys, multiplicity. And when the multiplicity is even, the correct math word would be tangent, right? But bounces is exactly what it does. So, and you know that it bounces at -3, right? So now, Garen, this is going to make sense to you, right? So I start up here, I go through 2, then when I go to -3, I got to bounce off, and then I connect, okay? So I like to use the mnemonic COTE, right? And again, that's the mnemonic I use. If you want to change tangent to a B for bounces, totally fine, I don't care. But it crosses when the multiplicity is odd, so that'd be a 1 or a 3 or a 5. It's either tangent or bounces when it's even. Right? So let me do a crazy one. Let's take one from, I don't know if there's a crazy one on your worksheet or not. Let's take a crazy one on your worksheet. Let's just take this one. This one's my next one. All right? So let's put a 3 on this one and a 4 on that one. All right? All right, so what are the zeros? Where's it hitting? Where's it hitting? +3, 0, the first one, and -5. Right? So this is what I like to do. I like to say, okay, this one is even, and this one is even. So you can put like a little B on there. 3, I know it's going to bounce. -5, I know it's going to bounce. Right? So I don't put anything when it's going to cross. All right, what's the degree? So I add them all up. 3 + 4 + 5. 12, right? So the degree is 12, which means it's even. How about leading coefficient? Negative, right? So negative, right-hand side down. Even is the same. Brennan, question? Say that one more time. Thank you very much, right? Which changes it, right? Right, so I did 3 + 4 + 5. He fixed me 3 + 4 + 2. So that's 9, which means it's odd. Then I try to go too fast. Thank you. Right? Negative still means I'm going down. Odd means I'm going opposite. So I'm going to connect what I know. I'm going to bounce. I'm going to go through this one. I'm going to bounce. And then I'm going to end. Connect the dots, right? So the only thing we are adding in today is when something is factorable, we can find the degree by all of that. It shows us where it hits the x-axis. Nothing different. I can still write its limits. Right? I can still write its limit lines as I'm doing the graph. Right? So let's look at the packet. Right? And let's see how much you can do for the packet. Some of them are like multiple choice, so they're going to be really quick. Okay. So these first 4, right, are multiple choice. So all you have to do is say, all right, letter A, it's hitting at -3, +1, and +5. Well, it looks like F and K have -3, +1, +5. Which one is it? Which one is A, F or K? It looks like this. So right-hand side is down. Right? I hear an F. Adam, what did you say? K. Why are you determining K? Negative is right-hand side down. So this guy is K of X. Right? So you're gonna decide which one it is. Okay, these bottom ones, you gotta graph it, exactly what we did. Now, I didn't get to one that had a number out front. All that is, guys, is a vertical stretch and shrink. So all that does is make things fatter or thinner. So for our purpose, you can kind of not see that 2.5. All right, so those are drawing them. So are the next page drawing them. C and F get a little harder. So I want you to give it a try, all right? Actually, C, E, F, G, and H get a little harder. All you need to do is factor them, right? So this one, G, I'll factor G for you. If I take an X out as a GCF, right? GCF, give me 1 second, guys, right? Then you can factor it just like the problems we had. So you've got to go all the way up to that 3rd page. Right?
It's not of this page, this page, and this page?
Yeah. But this first page is pretty much already done. You don't have to do that. So you're going to do multiple choice, the back of that page, and this page. Okay?
That's enough.
Well, graphs. Thank you.
To do senior project paper.
Oh, yeah.
Yo, that count?
Yeah.
Thank you, guys.
Can we not do this right now, Brennan? My patience? You've literally done that before.